Okay, so last time I was doing some more skinning. For this one, well, since then I've kind of finished the first pass of the skinning. So all my arms and fingers and everything, it's been skinned along with the head. So it took about, I would say, maybe 3-4 hours to do everything. For the inside of the mouth, I noticed it wasn't welded with the lips, so I spent some time to weld it the same way I did the head with the body. So it might be worth doing that because it gets annoying to try to do the skin from the inside of the mouth to the outside when it's not welded. It always leaves gaps, so I try to correct that. Okay, so for this part, what I wanted to do first, I wanted to clean up this character. Something I should have done like right away at the start, because it's all in triangles and it gets cluttered. It makes it hard to see when I want to go in wireframe because there's too many edges. So I want to clean it up and remove the triangles and just keep quads. So all these edges that are going not straight up or sideways, I'm gonna remove. So I can start. It won't matter for the mesh. I mean, as long as I don't move around the vertices, the shape of the mesh won't change. So I just have to keep all vertices and not move them around. So this is very important if I want to keep the shape of the mesh. Something else I did, I moved the bone of her breast downward a little bit. Well, you see, we can't see very well because of all these edges. This is a shoulder, and this is a breast. So at first it had the pivot point of the neck, so it was going all the way up there. But as I was doing the skinning, I noticed it was too far up. So if I wanted to move the breast, it would create, I don't know, it would deform the character too much in an unnatural way. So I moved them back down a little bit and a little bit forward. So that way it has a more natural movement that I can do. Okay, so for the edges, I'm gonna go back in like this. So I'm just gonna go in the editable poly, grab the edge sub-selection. This will be kind of long because there's just so many. So I'm just gonna go. I'm gonna try to keep all these edge sideways here, and just try to keep quads. I'm just gonna select them won't even bother the mirror if I want to mirror skin and something like that. It doesn't matter if the edges aren't the same as long as the vertices remain the same. So go here. This might be tricky at some places, in some areas. Alright, let's have these edges that I want to remove. So for this, just hold the Control key and then press the backspace key. That way it will just remove the edges without removing the whole surface, the whole poly. Hold on, I'm just going to keep this one here. Okay, it's not the same exactly, so this. Then I can grab this one. So I'm just going to go ahead like this for the whole character. I'm going to pause the video while I do this, and then I'll come back once it's done, and I'll proceed with what I want to do next is to add the twist bones for the legs and the arms and the neck. So I'll see you then. Okay, so after many hours of work, I finished removing all these unwanted edges, and now I have a much cleaner character. It's not as heavy to look at anymore, especially when I go into wireframe. It's not as cluttered, so I can more easily work my way into it. So now, actually, the way I did it, I actually did it manually to remove the edges. There's another way, a much quicker way to do it. It's basically you just select the selection. Unless that's freeform. I need the character selected, and I think I need to be in edit poly. For example, if I grab, I select the whole character. Here I have the option, where is it? Not a selection, it's in, it's right here, into the geometry. Yeah, and there's the option here, quadrify all. This will basically, as much as it can, just create four-sided polys while keeping the shape of the mesh. So it will just remove edges where it can. It kind of does have a good job overall, but it will leave some flaws at some areas um, that I'm not a fan of. But um, if you want to do a quick job, that can work. I just prefer to do it manually for the most part. For the part I knew I wanted clean like this, like the arms and the chest and the legs and whatnot, and especially for the head. So all of this I did manually, and it actually helped me locate areas where there was some welding necessary still, such as with the earrings, they weren't welded correctly, and so on. Now for the inside of the mouth, I use that tool, the quadrifoil, because it doesn't matter so much inside. We don't actually see a whole lot of it. We won't see it often, so it's just when she opens the mouth here. Now we can see the tongue and the teeth, and all the rest. That's the kind of job it will do with that tool. Just to give you an idea, it's very clean overall, but it's just the little flaws it leaves sometimes that I wanted to avoid. Okay, so now that's done. It actually broke my skin, so I had to spend some time to redo my skin, and I actually had to redo it pretty much from scratch. Okay. Next, first I want to bend her arm a little bit to have it not so straight as for her default position. So what I'm going to do, I'm just going to take the arm here, the forearm, and hold on. Am I in angle snap? Yes. Just going to bring it 15 degrees. Going to do the same thing on the other side. Do this, especially for when I'm gonna set up the IK chain. That way, I'm sure that the IK spline will be on the other side, and this swivel will be backward where the elbow is, so it has a more natural movement, and it won't snap or do weird movements on its own, or just bending on the wrong side. So this way, I'm sure I have the angle of on the right side. So now that's done. I want the mesh to have this position as its default position. So first, I'm going to select the bones I just moved, and then I'm going to set it as skin pose. Next, I'm selecting the mesh alone. I'm going to copy the skin, and then I'm going to collapse the skin, and then I'm going to paste the skin. Now it moved a little bit, but I just need to uncheck and recheck the always deform checkbox, and it should move back to its proper place. Now that way, so I'm just going to copy this skin, just making a little test here to be sure. I'm just going to delete it and paste it back. And now you see it didn't move. So the mesh has its position as I want it. This is a process we just call baking a skin, baking a mesh in a position we want. So you basically just move the mesh in a position you want. It could be any position, and then you just collapse the skin on top, and it will cause the mesh to have that position frozen. Okay, so for the next part, I want to go ahead and create the twist bones I'm going to use. So for this, first I don't need to have the mesh in the way, so I'm just going to hide it. Why is my mesh not? Okay, I need to select this, cut, and put it in mesh. Okay, just to have things separated correctly. So I'm gonna hide the mesh. That way it's not in the way I can see clearly where I place my bones. Oh yeah, first, one thing I want to do, I'm gonna run a little tool I made. Because if we remember, all my bones have this box shape, but it's just because I checked the display as box property. So these are my current bones, but I actually want to have boxes. I want my bones to be boxes, but not the eyes. I'm not going to do the eyes. The eyes I'm going to leave as such. Was there anything else? Oh no, it's alright. I think I need to make sure it's not about selection, was it? My tool. No. Hold on. Okay. Okay. It's this part here. I want to make sure that it only affects bones, and this is the part I need to add. Okay, and I want to exclude the eyes. So if not match pattern, name pattern quote star I star end quote, then okay. So now it shouldn't affect my eye bones. They all have eye in their names. So this function, what it will do it will convert my bone object into box objects. One thing we need to remember is the bone and the box have their height and length inverted, meaning the length of the bone is the height of the box and the height of the bone is the length of the box. So I had to save these values into variables and then put them into their proper properties of the newly converted bone into a box. And this is an offset for the object to put it back in its place. So that's basically what my function does. It's just as simple as a few lines of code. So if I run my tool, I'm simply going to press the Convert to Boxes button. And this will affect every bone except for the eyes. And there you go. And now all my bones are boxes. If we check into the local view, we still have their axis going in the same direction they were going while they were bones and not boxes. So it should be fine. There we go. Alright. Next, I do have a tool that I created to create the twist bones. I want to modify it a little bit because this tool that I made uses a wire parameter feature to twist the bones, but I want to use something different because the wire parameter causes some twisting that I didn't want. For example, when I was rotating the hand up and down, it would twist the forearm, which I don't want. I only wanted it to twist while I was rotating on this side. So I'm going to modify my tool. Wrong one. First, before I do that, I'm going to reselect everything here and set it back display as box so I can see through. Now the way I will do my twist bones, I'll start with one. For the twist bones I use helpers, a point helper, and I like to use the axis tripod and as a box and whatnot. So let's see the size I want. I'm just going to create a point. I guess I'm going to use the box also. Okay. So now I have a point. I'm going to align it, let's say, to my left upper arm. Now I see my point is a little bit big, so I'm going to resize it. aligned it to my upper arm. So now it has, it should have the same, I need to align the rotation axis also. There you go. Okay, so now it doesn't move. Now, for each limb or part of a limb, for example, the upper arm is a limb and forearm is a limb. For each part, I'm going to use 3 twist bones, so that will make it smoother when it twists, and it will help keep the mass of the mesh. So now I have the height at 28,162, so I'm going to copy this. This is the height of my bone. I'm going to divide it by 2, so that's 14,081. That's not what I want. Cancel. I want the twist bone that I just created. The point. I'm going to copy, make a copy. And here I'm just going to enter a line of code. Actually, I'm going to do this in my script here. I'm just going to open a new window for this. It's just for a test. Once I've done this test, I can use my code and to make it so that it will create every twist bone everywhere and set their proper values. So I want the second twist bone to be halfway in the inside the upper arm. So this is bone upper arm. I'm gonna put this bone into a variable. I'm gonna call it p bone equal $, apostrophe, and bone upper arm apostrophe. So this will store my main bone into this variable. I did calculate the height of the bone, but actually I'm gonna do it via code here. So I'm gonna say p height equal p bone dot height. So now I have my variable storing the value of the height. Next, hold on, I need to think a little bit. Okay, I'm gonna do it via selection. That way I'll just declare the object I have selected and apply the code onto that object. And I'm just going to update my code manually for the other bone that I'm going to create. So I'm just going to say dollar sign, which represents the object. If I don't name it the way I did this here, it will simply use my selection. Point transform to give it its position into the world, equal it pboom.transform. No, I'm going to use this. I'm going to put this into a variable. Transform of pboom. Pboom.transform. There we go. So I'm going to say this is the value here. Plus, for those who don't know it, the transform value is it's a value that, for example, I can just show it here. Just print $.transform. So it gives us a matrix 3, which is a set of 3 vector represented by 3. It's a 3-point. This is a 3-point vector, and there are 4 of them. So basically, this is it's kind of complicated to explain. So I'm not going to spend too much time on it. But it pretty much sets up its position, rotation, and scale value into the transform. Hold on, I need to spend a little while, so. I know I have it somewhere. Okay. Okay, I got it. So this is to set up its initial value. Next, I'm gonna say $.pause. No, I need to set up the imports syslocal $.pause equal. this is what I want. Need to replace this by this. The height divided by 2. Okay. So what it will do in this line here will place my my bone here. It will give it the same exact position coordinates as my parent bone, my main bone. And next it will move it into in local. It will move its position. This is for the x axis, y and z. Now I know I want the x-axis, and for the value, the y and the z value, I put at 0 because I don't want to move them. And for the y value, the x value, I use the height of the bone divided by 2. So that's pretty much what it does. So if I select this, and then I select my code, and I run this by pressing the enter key on the numpad while I have the code selected, for the lines I have selected, it should move it. And there you go. Now I know it is exactly midway inside the bone. We can see the value here. Yes, this is this is the value we saw earlier, which was the height, and now we can see this is the value it moves on the x-axis. So my code worked. Now if I want to create a third one, say OK, and I'm going to remove the divided by 2 and run this. It should move it at the end. So now I have 3 twist bones. Okay. I can select my 3 bones, and I'm going to link them on the upper arm. Just going to get this. I'm going to add a twist here. Oops. And give it a value here of 0 because it's the start. Or is it? Well, I'll figure it out later on. Might have to. This is why I'm doing this test, just to figure out which way is which. 50 for 50%. And 100 for 100%. So now if I rotate, they all follow because they're linked. Yeah, I did the 0 correctly. Now what I want these to do, I want them, for example this one, I don't want it to rotate at all. This one I want to rotate at 50% of what my main bone rotates, and this one at 100%. gonna do the twisting, I'm gonna use another helper. This is the ExposeTransform, Expose TM. Which is hold on, why is it called something already? Oh, okay. So this is basically another helper, but this one contains information. So I'm going to use just a simple box for this. I'm going to make it smaller. I'm going to link it on my parent bone. I will rename it rig XPTM upper arm L. I'm going to give it a different color so I can locate it more easily. I'm going to use let's say a yellow. Alright, here I need to select a node which will be the reference, meaning this this helper, what it does is will extract different values, different information about a node I'm going to pick. So I'm going to pick my upper arm, and we see here the local Euler angle values, which I'm not quite. Hold on. Oh yeah, I know why. Okay. Now I have all these values here in world, local, position, wall position. What I want to use, I want to use the local values. And for this arm, I want my twist bone to twist only when I rotate the x-axis. So, to make it easier for everything and for the calculations I'm going to use in my code, I need these values here to be at 0. The way it works for local values, these are this is its x rotation values in reference to its parent. In this case, this is the shoulder. So, to make it 0, I only need to have a parent that has the exact same transform value as itself. So I'm just using yet another point helper. Place here. I'm going to give it different. I'm going to make it bigger, let's say. And just code it, color code it. I'm going to put it red.
Actually, these I want to make my twist bone distinct, so I'm going to make them orange. There you go. So basically I'm just going to grab my bone and reparent it. But first I'm gonna parent this one to my shoulder, and my upper arm will become the child of this this new helper that I put there. I just aligned this helper with the upper arm. So now if I go back to see my ExposeTransform node, we see here all my values are down. They're down to 0. I don't like the minus here, but I don't need the Y and the Z axis, so it should be okay. Now if I make a test, we can see it works correctly. It works correctly. Okay. Now I'm gonna set up my twisting. What I'm gonna do, I'm gonna go into the controller panel and go into the rotation section, and then here on the X axis, because this is the axis I want to affect, I'm going to use a float script. There we go. This dialog box will open. Now we can see the expression is 0. This is actually its X value for the rotation, again in reference to its parent. So as its parent, it simply means it has the same rotation in X as its parent does currently. Okay, so now I need to create a variable which will be my P driver. I use the letter P simply. It's kind of a way to name my variables. This represents, for me, it represents just a node, like any node. And for this one, since this is a driver, I'm going to assign the node. I'm going to go get my shoulder. There's a point 1 that I didn't rename. I need to do that. And this is the bone upper arm that I want. So now my bone, my bone is stored into this variable. Actually, I did the wrong thing. This isn't. Well, it could work, but this isn't the way I want to do it. So hold on. I need to. I'm gonna restart this. Driver. Again. Actually, I want to go get the value inside my ExposeTransform. So. What was it again? Rig ExposeTransform. Okay, this is it. And I want the local. Why can't I select it? Oh, because this is the node. Assign track? Yes. It's a track, apparently. So I'm going to get the local Euler X. And the expression will be, I'm just going to make a test here. I need to P driver multiplied by 0. It should be. Okay, if I test, no, it doesn't work. Hold on, I'm just trying to figure out. Is it simply P driver? Okay. Multiply by -1. Nope. This is actually the reason why I do this manually at first, because I want to find out my values that I need. And I think I'm doing this wrong right now. Or is it simply, I'm going to pause the video and do a little bit of research on this, and I'm going to come back. Okay, so now I figured it out. I needed to add this part here, the deg to rad, degrees to radius value. Well, this function. This is what I needed to add. So what it does, it basically it pretty much, this twist bone actually, its purpose is to not twist, because when you try to twist an arm, the area around the shoulder won't actually twist, though the part that connects to the shoulder. But the skin that gets close to it will be slightly affected by the middle twist bone. So if I make a test here, we see my twist bone doesn't twist. And now I'm kind of wondering why the other ones, okay, they're good. Yeah, they're good, it's alright. So, I'm going to copy this. And I'm going to go to the next twist bone and do the same thing. Float script, P driver to add variable, add a track, and go get. My expose here, object, and local Euler X. There we go. I'm gonna print. I'm gonna paste my code, but for this one, instead of the -1, which pretty much counters the value 1 for 1, this one I wanted to counter it only by half. So minus 0.5. Evaluate. Now if I make a test, we can see it twists only at 50% of the full twisting of the upper arm. And then for the last one, float script, driver, create slang track, local X, hold on, I need to not be confused. Is it simply one? Kind of doesn't make sense, but hold on. I'm gonna test if it works. And now it's going twice as fast. Let's say multiply by 0. Oh yeah, this is it. This is simply to multiply it by 0. Now we can see the full twisting of my upper arm. And the area of the elbow will follow completely, and the area around the shoulder will simply not follow at all. So I'm going to assume skin post, which just broke everything for a reason I'm going to find out. Oh yes, I know why. Because this is because I added a new parent for this bone. So now its skin pose is kind of messed up, so I simply need to, hold on, I'm just going to reselect everything here and then reset the skin pose. And now if I try it again, assume skin pose, alright, now it works correctly. Okay, so this is pretty much how I'm going to go about for the twist bones. It's just important to remember what the driver is. In this case, the driver is determined inside my ExposeTransform node. Here, which will extract the value I need. For the forearm, the way I do it, the driver will be the hand, and it's the same thing. I'm just gonna roll this. It's the same thing for the legs. The thigh will be its own driver, but for the calf, the driver will be the foot. So as the foot twists or moves on the side, the calf will twist. So this is pretty much how I go about. There's a way to, this is what I'm going to do on my own now, will be to make a little tool that will just create everything like this automatically for every limbs. There will be, well, what's important is for the limbs, I add some for the neck also. I had 3 of them. And for the neck, the difference is that it will it will have three values. It will have a script on each of its axes because it can twist in every direction. So like this, and back and forth. So since it goes in every direction, I'm going to add a script for each of them. So I'm going to end this video here, and when I come back for the next video, I'll have all my twist bones set up. And that's it. Hope you enjoyed.